Hello and welcome to the shorter form content of Better Together with Shinrai Sensei. Today we are returning to math and we are going to be working on decimals. Multiplying, dividing, adding, subtracting. So everything that we can with decimals is going to be done. So, go ahead and erase some of the one example that wasn't quite legible anymore. So, as I said, today is all about decimals and the best ways to do math with them. Obviously we're figuring you don't have a calculator. This is all basically practice for if you ever have a situation where you need to kind of just be able to do this on a piece of paper. Here you go. So I'll write my examples back up here, right? Now, so adding and subtracting decimals is pretty simple. You just got to make sure that every decimal point is lined up. And then if, say, I have a decimal that's written, in this case I have 27.91, but instead of 5.43, let's say I add 5.4. Well, you have to figure that just for the sake of clarity, you want to put a 0 there. That way the number of decimals behind the decimal point is the same, and that way you can do your math straight up and down, right? But that's not the example we're going to use. We're going to stick with the example that's already on the board. 27.91 plus 5.43. Now, this is also useful in terms of how to do long addition, right? Because you get long addition is basically just these. Let's say you get a 4-digit number and a 3-digit number being added together, but there's no decimal point. That's just long addition, right? If I made these decimal points disappear, then these decimal points would be complete non-entities in this situation, right? Now, in the case of 27.91 plus 5.43, the 1 plus 3 is 4, 9 plus 4 is 13, and you carry that 1 up top, add it to what 7 plus 5 is. So 7 plus 5 is 12, plus 1 is 13. Carry that 1 over there, and 2 and 1 is 3. So 33.34 is the correct answer for 27.91 plus 5.43. And in the case of 33.41 minus 8.93, obviously you cannot take a 3 from a 1. So you have to reduce this number to a 3 in order to make that 11, giving that a value of 11 now. And that makes this 8. Once again, you cannot take 9 from 3, so we have to make this a 2 to make this 13. And then that's 4. But you can't take 8 from 2, so this becomes a 2 as well. This becomes 12, and that becomes 4. And 2448 is the final answer for 33.41 minus 8.93. Okay? So addition and subtraction for decimal points is the exact same addition and subtraction you're going to be doing for long addition and long subtraction, where you have 4, 5, 6, 7, 8, 9, however many digits, really big numbers that maybe you've never even seen, that many numbers anywhere, or like that many of anything in your life, That's how you do long addition, but that's also how you do addition and subtraction for decimal points, right? Now, when it comes to multiplication of decimal points with a whole number, it's pretty simple. You just multiply like you normally would, and just remember to keep the decimal point in the same place as the original decimal, right? So we have 2 decimal points behind the digit. So there's going to be 2 decimal points here. And also in this, you will have to, for the answer, when you're writing it down on paper, you have to include every 0 that is behind. Because if you don't, then when you move the decimals, you're going to move the decimals too many. And you're going to end up with the wrong answer, right? But in this case, 2.53 times 4 is 4 times 3 is 12. You carry that 1 up there, and in this case, it's just like the addition, except in this case where you go 4 times 5, it's not 4 times 5 plus 4 times 1. It's 4 times 5 plus just the number 1. Okay? And then you go ahead and do that. So 4 times 5 is 2, 0, which is 21 or 20. But now it's 21 because you have to add that 1. And then after that, you've got the 1 down here, you carry the 2 up here. And then 4 times 2 is 8, plus 2 is 10. And so 2.53 times 4 is going to give us 10.12. Okay? Now, the example right below it is when you're multiplying 2 decimals. Now, when you're multiplying 2 decimals, the best way to do it, for clarity's sake, is going to be writing them out as whole numbers rather than decimals. So now I move that decimal point over and make both of these whole numbers. So now it's 121 times 190. And easiest way to do that is just multiplying 190 by every digit. So 190 times 1 is 190. 190 times 2 is 3,800. Or 20, sorry, 20. Because you got to figure this is 20 because of the place that that's in. That's in the tens place, not in the singles place, right? So 190 times 20 is 3,800. And 190 times 100 is 19,000. So 19,000 plus 3,800 plus 190 is going to give you 22,990. And now you have to move that decimal place back. The total of the number of decimals that you moved between these two numbers, right? So technically speaking, we moved this decimal point. We moved this over twice and this over twice. So you've got 2 times for that decimal point to be made into a whole number. So then we have to go 4 times back this way. So this went this way, this went this way to make these 121 times 190. So now it's got to go 4 times back that way in order to make it 2.299 is the answer. Okay? Pretty simple. And once again, this is the same thing you would be doing for long multiplication on paper. Is just you have to take one of the two numbers and multiply it by every digit that makes up the other number. All right? And by the way, digit is every place. All right, now, in the case of 4.5 divided by 3, right? So 4.5 divided by 3, well, you basically just pretend like 4.5 is 45, but you don't have to do anything to the 3 in this case because the decimal point is just going to move back 1, right? So, for 4.5 divided by 3, it's basically saying the same as 45 divided by 3, which is 15, and then you move that one dot backwards. You know, you move that one place backwards, and now you've got 1.5 instead of 15, right? Pretty simple, pretty rudimentary when it comes to a whole number and a decimal. Now, when you divide 2 decimals, you can do the same method as your long multiplication, which is making both of them whole numbers of the same kind, or same, you know, the same number of times you move the top number's decimal over or the bottom number's decimal over, whichever one has more decimal points, is the same number you have to move that other number's decimal points over, right? So in this case, the top number has two places behind the decimal, the bottom only has one, but you have to move them 2 places behind the decimal for both of them. But this time, the answer, unlike in the multiplication where you've got to do the decimal moving and all that stuff, you don't have to do that for division. The decimal stays exactly the way that the answer would be from this problem is the same that the answer is from this problem. So 452 divided by 40 has the same exact answer as 4.52 divided by 0.4, right? Same exact answer. So you don't have to rewrite this 11.3 at all in order for you to get the same answer. Because if you multiply 0.4 times 11.3, you'll get 452, 4.52. So the number's the same. The multiplication's really the only odd outlier, I should say, where you have to deal with figuring out how many decimal points to move after you do this. You know, multiplication is the most complicated part of doing math with decimals. Everything else is really simple, really basic. And then multiplication just comes in and makes everybody have a hard time. Anyway, I hope you guys have learned something new today. And if you guys have any questions about this, leave them in the comments section below. Or you can ask me at my Twitter handles, Shinrai Sensei 15. And please feel free to leave any other comments and like, subscribe. And I hope to see you all again next time.